Hello, welcome to this video where we look at the Year 10 linear graphing practice test. In this I will go through the worked solutions. I'm going to show pretty much every step for all the questions. It's not expected that you complete every single step in the working out. If there's some steps you can skip because you're being able to do some of these parts in your head, then that's completely fine. I just want to include every single step so that people can see how the answers are generated. Don't want to leave anyone behind. So let's get cracking. So question 1 is expand the following expressions and simplify where possible. So expand just means remove brackets. So we're clear on what the question is asking us to do, is just to get rid of the brackets. And the way we get rid of the brackets is using the distributive law. Now the distributive law is whatever's out the front of the bracket, we multiply by everything inside the bracket. Doesn't matter how long the bracket is, whatever's in front, we multiply by everything inside. So in this case, we get, this is the same as 2 times x, and then plus 2 times 3. So the 2 times the x, and then the 2 times the 3, and that then gives us 2x plus 6. Part 2 looks a whole lot harder, but it's just 2 sets of brackets. So it's whatever's in front of that particular set of brackets, we multiply by everything inside. So we're going to have that going on, and then over in this bracket, we're going to have this going on. So we get negative 2 times by x, and then we also get plus, and in this case it's the negative 2 times by 1. And that's the first bracket done. And then we do the second bracket, so we get plus 3 times by 2x plus 3 times by negative 5. Some people, it would have been fine over in this bit just here to have just gone, okay, it's the negative 2 times the x, and then it's the negative 2 times by the 1. You could do the adding the negative 2, but that's alright. The minus sign straight away there's fine. And then we start simplifying. So we get negative 2 times x is negative 2x. Negative 2 times 1 is minus 2. We then get 3 times by 2x, so we get plus 6x. And then plus 3 times by negative 5, so 3 times by negative 5 is negative 15. Bit easy to see. And then once we're at this stage, we actually have some like terms that we can collect. So we have a 2x there and a 6x there. So take away 2x plus the 6x, or negative 2 plus the 6, that turns into 4x. And with all these, feel free to use your calculator. That's what it's there for. Your number skills aren't up to scratch. We're not testing your number skills. We're testing your algebra and your linear graphing skills. And then we have the negative 2 minus 15. So negative 2 take away another 15. And that simplifies down to minus 17. That's our first question. Question number 2, factorize the following expressions. Well, factorize means put in brackets. So we're sort of doing the process in reverse. Okay. So to factorize, we're looking for what is common factors for each of the terms. So a common factor is a number or a variable, what we just call letters, a number or a variable that we can divide each of the terms by. What is something that we could divide all the terms by, and that's what we're going to take out as our common factor. So in this case, we have a 6y and a 30. Now both of these I can divide by 6. I'm allowed to divide by 6, so let's take that out the front. And then whatever's left when we divide by that 6, I'm going to divide by that 6. That whatever's left is what goes inside the brackets. So in that case, we did 6 divided by 6, cancel out the y's left. 30 divided by 6, if you do that, what's left is 5. So that's our answer there. In the second one, we have a 5x squared minus a 10x. What can we divide both of these by? Well, I can divide both by 5. And in this case, since they have the same letter, or same variable, I can also divide both of these by x. So we're going to do that. So since I can divide both of these by 5x, that's what I put out the front. And then we start doing some cancelling. So the 5 and 5 cancel. Now the x and the squared cancel, so that just leaves me x there. Now the 10 and the 5, 10 divided by 5, that leaves me 2. So we get minus 2, and then the x and the x cancel again, and since there's nothing else left there, that's it. So we divide both of those by 5x, that's what is left. Question 3 is about inequalities. So solve the following inequalities and graph their solutions on the number line. So solving means we need to rearrange these expressions, or inequalities I should say, so that we get the variable by the self. So our goal in all of these in solving is, be it inequalities or equation, but it's to get the variable by itself. Because that is then going to tell us, once we have it by itself, that's what it's equal to or unequal to in this case, since we're doing inequalities. So I want to move the 3, so we do this whole idea of doing the opposites, or do the same both sides. So 3a is actually 3 times a, which is less than 6. So what's the opposite of timesing by 3? We're going to divide by 3. And same on the other side, we'll divide by 3. So that cancels, that cancels. That's the whole reason why we choose opposites. It's going to cancel out. And that means all that we're left with is a, and it's less than. Now 6 divided by 3 is 2. So whatever our number is, and we need to put this on the number line, so whatever our number is, that's where we want to put our dot or circle. So in this case, we're at 2. And since it's less than 2, we don't fill in the dot. We can't, if we filled in the dot, we'd be including 2, but in this case, we have to be less than 2. So we don't fill in the dot. And since we want less than it, well, we want any numbers less than 2. Okay. Now this arrow that I've drawn here, I could have kept drawing it and kept going all the way to the end, which is probably a better thing to do. So any number less than 2. Part 2 is exactly the same way. We have 2b minus 6 less than or equal to 4, negative 4. So we want to start moving the numbers away from the b in this case. We want to move the 6 first, so what's the opposite of minus 6? We just plus 6 to that side, plus 6 to that side. That means that cancels. So what do we have left? Well, we have 2b left, less than or equal to, now negative 4 plus 6. Again, if you know our skills aren't up to scratch, just stick it in your calculator. We get 2. Now we have the 2b less than or equal to 2. We still need to move the 2 on the left hand side. Now this is 2 times b, so what's the opposite of times by 2? We are going to divide by 2. So we have to divide by 2 to both sides. That makes the 2 on the left cancel. So we are left with b less than or equal to, now 2 divided by 2 is 1. So we have to have b less than or equal to 1. So 1's our number, so we're going to put our circle there. Now since we can include 1, we're going to fill that circle in. Make it fully in, and again we want less than, so in this case we're going to be to the left hand side. So that's our inequalities. Okay. Question 4 is similar to question 2 in that we're trying to simplify by cancelling common factors. So we need to take out a common factor. And then once we take that common factor out, it will allow us to simplify with the bottom. The bottom of the fraction or the denominator in the fraction. So in this, we can, in the top, what can we divide both these terms by? Well, we can divide both those terms by 4. So the top, if we take 4 out, we're left with 4 divided by 4 is 1, minus 4 divided by 1. 4 divided by 4 again is 1, so we get 1 minus 1x on the top, and then we just leave the 4x there. Now, since we've taken the 4 out as a common factor, I can now cancel those 4's, and what am I left with? Well, I am left with 1 minus 1x equals, on top of x, sorry. Now this 1x here, we can also just write it as 1 minus x. That one or that one will be accepted as fine. In part 2, what can we take out as a common factor out of the top, or what's called the numerator? We always look at the top and we get a guide from what's in the bottom or the denominator. So in this case, we got a 5 in the denominator. So can we divide the top by 5? That's what we want to think about. Can we divide by 5 something in the top? And in this case, 10, yes we can. So we can take 5 out. Now, we also have a y in the bottom and we also have a y on the top, so I could take a y out as well. So what am I left with? 10 divided by 5 is 2. The x isn't divided by anything, so that's there. If we divide y squared by y, that leaves us with a y. And put that all over what our original bottom was. Now, we can cancel that 5y with that 5y. And we just write what's left behind. So we get 2xy. That's our answer. Now, some people may have been able to see 2x. Let me write out the problem again. Okay. They may just see the cancelling while I have a y and a y squared. So I'm going to cancel the y with the squared. That's done. I'm going to cancel the 5 and the 10, and that just leaves 2. And I just then write what's left, 2xy. I get the same answer. Either way is fine. The way on the left is what's technically happening mathematically. Is we have a common factor top and bottom, and then we can cancel down. Okay, find the equation of the following straight line. And this steps you through it. So this is our linear graphing work now. We want to identify what our rise and our run is. So we just pick 2 points. I'm going to pick there and there. I might in a bit for you. There we go. That's pretty good. Okay. So I'm going to pick those 2 points. There at -1 and there at 2. So that's -1. That's 2. And I pretty much just draw in a triangle between them. And in this case, I want to get my rise and run. So I need to go start at my left-hand point. What do? Well, I go up 1. And then I'm going to go across 2 to get to my other point. So I've gone up 1. So that's my rise. And I've gone across 2. So I suggest doing your up and downs first, and then your across second. That means you're not going to get your rise and run numbers confused. Go up or down first and then across as needed. So that's our rise and run. Now our gradient, which is m, just as a reminder, is always equal to rise over run, which we just got. So that is equal to 1 over 2, and we can just leave it as a fraction. You could put it as a decimal, putting a calculator to get a decimal. In this case, it's 0.5. But I suggest leaving it like that. Now we want our y-intercept. Now our y-intercept is where our line crosses the y-axis. So our y-axis is the up and down. I see a lot of people reading off that number there. That's our x-axis intercept, which is wrong. We need to cross where we cross our y-axis. And in this case, that was here at -1. So our y-intercept is -1. Now the last bit is we just need to write our equation. Now our equation is always equal to, for a straight line, y equals mx plus c, where m is our gradient and c is our y-intercept. That's equal to m, that's equal to c. So once you've found those 2 numbers, whatever they are, your gradient number and your y-intercept number, you can just put them in the equation. So we put our half there, put our x in, and then my y-intercept was -1. And that's my equation. Y equals half x minus 1. This second one is a little bit harder, just because the y-intercept's a little bit trickier to find. But we'll have a go. So let's start with picking 2 points. Now I'm going to pick this point since it's labelled. Sorry, my camera's just turned off. There we go. My apologies. I need to change the setting there. So I was picking 2 points where it crosses the axis, and then the point that's already labelled. So start with my up and down. So I need to go down from that point. Okay, starting at the left. Start at the left-hand side. Window just moved on me there. Okay, start at left, and how far down have I gone? Well, I've gone 1, 2, 3, 4. So I've gone down 4, and since it's going down, we call that negative. Okay, so my rise, I went down 4, which is equal to -4. My run, I've just gone across one. I had to go across one square. So what is my gradient? Well, my gradient is rise over run, which is equal to -4 on 1. Stick that in your calculator, that's just equal to -4. Now, our y-intercept's a little bit harder. We can't see, if I erase some of this, okay, we can't see where our line crosses the y-axis. Our y-axis is all the way over here. Okay? And we can't see where it crosses. What we can think of, though, okay, is we know this line's going to keep going up and up and up, and eventually it's going to cross somewhere. Okay? Now, how high up is that going to be when it crosses? We can look at this graph and realize, well, to go across this way, if I thought right to left, to go across this way 1 unit, okay, I had to go up 4. Okay? Now, I need to go across 1 more to hit the y-axis, so if I'm going to go across 1 again, okay, I need to go up the same amount as I did before to go up, so I'm going to go up another 4 from that point. And since I was already at 4, I'm going to go up another 4 is when I'll cross. So my y-intercept in this case happens to be 8. Now we can just use our equation is equal to y is equal to mx plus c, where our m and our c are our gradient and our y-intercept. And we get y equals -4x plus 8. So we're just changing out our m and our c for the values we just found. Third one, we're given this point where it crosses here, that's 3. Now, there's no other spot particularly labelled in this problem. You could pick anywhere in the line. I could pick here, I can pick here, I can pick here, I can pick here. But you want to pick a spot that makes sense. You don't want to pick, say, that spot right there that is 2.5 across and what's that? That's 3.8 up. You don't want to pick a random spot like that. Let's try and pick one that's on a nice spot where it crosses nice whole even numbers or meets at a point, which happens to be right there. That's 3 across and it's 4 up. That's a good spot to pick, and it's easy to count our rise and our run. So we start at our left hand side, go up or down as needed. So I need to go up. How far up did I need to go from the point? I only need to go up 1, so my rise is equal to 1. How far across did I need to go? Well, I had to go across 3, so my run is 3. Gradient is equal to rise over run, which is equal to 1 on 3. My y-intercept I can see. It's where I cross the y-axis. And what's the number there? The number there is 3. So my equation again is equal to y equals mx plus c. Put in my m, which is 1 over 3, x, put in my c, which is 3. And that's how we get the equation of the line. Check how this is going. Hopefully that little box disappears. Let's zoom back out. Okay. Now, question 6 is about parallel lines. If a line has an equation y equals -3x plus 3, what would be the gradient of the line parallel to this one? So this question has 2 parts. Being able to read the parts of an equation and then recognizing what's important about 2 parallel lines. Straight off the bat, that's my gradient. And that's my c value or y-intercept. What's special about parallel lines? Any two parallel lines have the same gradient. So if there's a line parallel this, it must have the same gradient. Now, the gradient number in that equation is -3. So what's the gradient of the line going to be parallel to? It's m for gradient is going to be equal to -3 of any parallel line. Question 7. Come up with 2 equations that are parallel lines with a positive gradient. So this is where we're looking for you to pick your own equations. Okay? We don't care what they are, but you need to pick 2 that have the same gradient. So it's relying on the same skills. You can pick any number you want. They just have this. They have to be parallel, and in this case, they have to be positive. So the gradient number needs to be positive. I'm just going to pick m equals 2. Okay, make it nice and simple for myself. So equation 1, I'm going to say y equals 2x because I need to have that gradient. And then I'm just going to pick a random y-intercept. I'm going to pick +1. It's going to be nice and easy to graph. And it's on this grid below because later on it's going to ask me to graph them. My second equation needs the same gradient, so it needs to be the 2x. And I'm going to pick a different y-intercept. I'm just going to pick -1. The second bit of this question is asking for two equations that are again parallel, but this time a negative gradient. So I need a gradient that's negative, and they both have the same gradient. I'm going to pick m equals -1. So I get y equals -1x, and same here, this one also needs to be y equals -1x. They have to have the same gradient because they're parallel, and then I'm just going to pick random y-intercept. So I'm going to pick +4, and I'm going to pick +3. Okay. So now we need to sketch them. I'm going to do these two first. Okay. Gradient of 2 and the y-intercepts. My hint for graphing is first is put the y-intercept, and then 2, count out, rise and run. Put second dot, and then connect the dots. So in this case, my first one, which is y equals 2x plus 1, my y-intercept is +1, which happens to be about there, halfway between 0 and 2. And then my gradient, my m, is equal to 2, which I can write that as, because we want to think of what's my rise, what's my run, that's actually the same as 2 over 1. Any number is the same as its number over 1. So I can see that that is equal to my rise, and that is equal to my run. So I need to count up 2 now. So I'm going to go up 1, up 2, takes me up to 3. And then I have a run of 1. I go across 1, and that gets me my second dot right there. And if I had a rule, which I can't really do on this program, I don't think. No, I can't. So you'd use a ruler, but you draw a straight line through those. Not having a ruler makes it really difficult. Well, that's the first one. Let's do the second one. Okay, same thing, start with my y-intercept. In this case, it was -1, so that's down here. My gradient is the same, which was m equals 2, which is the same as 2 on 1. My rise and run. So I'm going to count up my rise of 2. So I'm going to go up 1, up 2, gets me to there. Then I'm going to go across my run, which is 1, which puts me right there. So I have my 2 dots. And I'm going to connect them. Oh, that's a terrible line. And again, I haven't done this with a ruler, so it's hard to see that these are parallel. But they are, if I did them with a ruler. Equation 3. Here, y equals -1x plus 4. So I start with my y-intercept plus 4, put that there. Now my gradient in this case is equal to -1, which I can write as -1 on 1. My rise and my run. So in this one, I'm going to go down 1. Since it's a -1, I need to go down instead of up. Go down my -1, and then go across my 1. That gets me a dot there, and I connect the dots. Finally, onto my last equation, y equals -1x plus 3. My y-intercept is 3, which is there. And then my gradient was -1, so same thing, equals -1 on 1. So I'm going to have a rise of -1, so I need to go down 1, takes me there, and then run across 1, which takes me to there. And that's my 2 dots. Those, and there's my two sets of 2 parallel lines. I'm just pressing that button on the camera to stop it going off. Righto. Okay, question 8. State if each of the following coordinates fall on the line y equals x on 2 plus 3. So the way if we check if coordinates fall on a line, okay, is step 1, sub in the x value, solve, and then solve, so simplify the right hand side, solve, I'll just put RHS means right hand side, so the bit where we put in the sub in the x value, and then 3 compare to the y value. And I'll show you what that looks like. So this is my x, that's my y, so I'm going to sub in the x value, so I get y equals, I'm going to put -2 on 2 plus 3 for the rest of it. -2 divided by 2 is -1 plus 3, that gives me 2. I then compare this, because that's my y equals, to what the y set up here. Okay? In this case, I had -2 up here. Down here I have +2, so no, that doesn't match, so no, that doesn't sit on the line. That coordinate, -2, -2, doesn't sit on the line. Let's go again, so this time we've got 3 and 4, so that's my x, that's my y. I get y equals, now where the x is, I put in my 3, divided by 2 plus 3. Y equals 3 on 2 plus 3. That gives me, 3 on 2 is 1.5. 3, so y is equal to 4.5. I check, compare to my original y, and they don't match, so no, that doesn't sit on the line. Let's try it again. Let's see if we get one. Okay, that's my x, that's my y, so I sub it in, so y equals 2 on 2 plus 3, y is equal to 1 plus 3, y is equal to 4. Compare, and they are the same this time, so this coordinate 2, 4 does sit on the line, so the answer is yes there. Last one, go again, x, y is equal to -6 on 2 plus 3, that gives me y equals -3 plus 3, that gives me y is equal to 0. Make the comparison, they match, so yes, that sits on the line. Rightio, okay, getting through it. Find the gradient between these following coordinates. So this is when we're just given coordinates. How do we find the gradient? Now this is where we have to use the equation m is equal to y2 minus y1 divided by x2 take away x1, where the first point, this is my first point, that's my second point, so this is called x1, y1, this is called x2, y2, and you just have to sub those numbers into that equation every time. M equals y2 take y1 on x2 take x1, that gives me y2 is 7, so I'm just reading using this key up here, putting them as needed, minus y1 is 4, divided by x2 is 9, take x1 is 3, that gives me 7 take away 4 is 3, 9 take away 3 is 6, that simplifies to a half. So that's my gradient between those 2 points. And we just do the same thing. M is equal to y2 take y1 on x2 take x1, where that is x1, y1, x2, y2. Gives me 12 take away, and this is where we have to be careful with signs. We have a take away in the equation, and then this is -8 on x2 is 2, take away -2, 12, 8, that's 20 on 4, that turns into 5. Again, use your calculator to help solve that bit if need be. And then same again, x2, y1, x2, y2, m is equal to y2, take away y1, x2, x1, gives me 20, take away 5 on 15, take away 6, ends up being 15 on 9. And divide both of those by 3 to simplify, gives me 5 on 3. Or whatever your calculator gives you as a decimal. Question 10 and 11 are both formulas again. Finding the distance. So the distance is equal to the square root of, and then we get let me get this right. x2 take away x1 all squared plus y2 take away y1 all squared. Now you can do this whole bracket over here and this whole bracket. They can be switched. Either way works. You could do the y's first and then the x's second, or the x's first, y second. Doesn't matter which way. It's going to give you the same answer. But same thing, x1, y1, x2, y2. So the distance between those 2 points is equal to the square root of, now x2 is 4, take away 2, all squared, plus bracket y2, 6 take away 3, all squared, gives me square root of 4 take away 2 squared plus 3 squared is equal to the square root of 4 plus 9 is equal to the square root of 15. You could then put that in your calculator if you wanted to and find out what that is, or you can leave it as the square root of 15. That's completely fine. If the question says find the exact distance, you must leave it in the square root sign. You can't give it to us as a decimal. You need to leave it in the square root sign. This second one, same thing, x1, x2, y2. Distance is equal to the square root of 2 take away negative 6. Again, being careful with signs. It's a negative 6. My notation might be a little bit odd, but that's also, you could write it plus y2, so negative 4 take away 5 all squared equal to the square root of 8 squared plus negative 5. Negative 9 squared, that gives me the square root of 64 plus 81, because the negative 9 squared turns into plus 81. That gives me, without a calculator, 6 and 8, 145. But you could use your calculator to get that. Rightio, midpoint. Another equation, like I said, is equal to, midpoint will be equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. That's just the averaging of the 2 points. This one important, in order is important. You must do the x's first and then the y second with the comma in between, because we always write our coordinates as x, comma, y. So that order is really important for that question. So we have x1, y1, x2, y2. Sub them into the equation. We get 2 plus 4 divided by 2, comma, 3 plus 6 divided by 2, comma. We get 2 plus 4 is 6 divided by 2 is 3, comma, 3 plus 6 is 9 divided by 2 is 4.5, or you could just leave it as 9 on 2. Or it'll be 3, comma, 4.5. Either one of those will be fine. Same for the other one, midpoint. Now I might, instead of using m, because we use that for gradient, I might actually write the word mid. It is equal to. Just to help try and avoid confusion for you. So we get negative 6 plus 2 divided by 2, comma, 5 plus negative 4 divided by 2, comma, close bracket. Negative 6 plus 2 is negative 4. Get negative 4 on 2, comma, 1 on 2. That is equal to negative 2, comma, half. That's it. So question 9, 10, 11 are just substituting into equations. Make sure you have the equation written down in your reference book and maybe one of these examples from each of them so you do it correctly. Question 12 is our applied problem, so a worded problem. So it's using the idea of linear equations to help solve a real situation. Okay, a new breed, not bred, that should be breed, of bamboo has been developed that grows exceptionally fast to be used in construction. This special bamboo starts at 50 centimeters tall and grows at 2.5 centimeters per day. Complete the table below that shows the height of the bamboo each day. Well, it starts at 50 and it goes up 2.5. Goes up 2.5. Goes up 2.5. You get the sort of idea here. So if it's starting at 50, that means it goes to 52.5. Then write this a bit neater. 52.5, 55, 57.5, 60, 62.5, and 65. Okay. Write the equation for the growth of the bamboo in the form of y equals mx plus c. Now, if we think of this as a bit of a graph, okay, where this is days going across this one, and then that impacts the height of the bamboo at its 0 day, 1, 2, 3, 4, etc. It starts at 50, goes up 2.5 in a day, so it's there at 52.5, and that pattern keeps repeating, and it goes up like that. So we can see from this idea, or what its height is at its 0 day, that is equal to its c value, its y-intercept. That is equal to its c, and then how much it's going up to, if it's going up by that in a single day, that is equal to our gradient. That goes up 2.5 over going across 1 day. So our gradient is 2.5 divided by 1, which just gives us 2.5. So I could write this as an equation, okay? Y equals 2.5x plus 50. Okay? Or if we want to be really correct, we're not dealing with y and x. In this case, we're actually getting x is how many days has gone by, and y is the total height of the plant. So we could maybe call that d, and we could call this h. So we get h is equal to 2.5. d, whatever the days is, plus 50. How long would you have to let the bamboo grow to be 100 centimeters tall? So we want to find, okay, height is 100. How many days does it take? Now you could go, okay, well it goes up 2.5 each time. I'm starting at 50, I need to go up another 50. I'm going to divide that 50, I need to go up by 2.5, figure out how many days. That could work, or we could just go, well, we've got an equation, h equals h is equal to 2.5 per day plus 50, and I know the height's going to get to 100, so I can put that in, so I get 2.5 days plus 50, and then I can start rearranging this by using our algebra skills. So take 50, that cancels, so take 50, so I get 50 equals 2.5 d, divide both sides by 2.5, that cancels, and I'm left with 50 divided by 2.5. Let me think about this. 20? Yeah, gives me 20 equals d. So I'd have to let it grow 20 days. So you could use the algebra like that, or you can just go with the reasoning. I start at 50, I need to get to 100. So how much do I need to go up by? I need to go up 50. How much do I go up per day? 2.5, so I divide that 50 by 2.5. That tells me how many days it's going to take. That's all the solutions to the practice test. That's a long video, 40 minutes. But I wanted to give clear reasoning for every single question. Hopefully, if there's questions you knew how to do, you've just skipped through this video as need be. I hope this helps. If you have any questions, please hit me up in class tomorrow.